Recording has started.
All right. We're going to cover three topics tonight, the first of which is risks. The other two are fairly short, so we'll get at least a couple of breaks in here uh, while we change topics. All right. Risks defined as a condition of uncertainty. Okay. So notice that it's not necessarily negative. It can be positive also. Uh, when a risk is positive, it's considered an opportunity. If it's negative, it's considered a threat. Okay. So risks can come from anywhere, inside the organization, outside the organization, outside the corporation, from anywhere. Now, risks uh, are triggered, okay, by something they call a trigger condition. Okay. If a risk progresses to where it's uh, something is going to definitely happen with it, you've got to act on that. So here are the definitions first set tonight. All right. From the case study that we have, some of the project risks that were identified. We're working with new vendors and building processes, uh, supply chain issues for correct bricks, building code compliance, and a couple other in here, plus the one that I really like is site survey shows there's a risk of slippage from coastal erosion in less than 25 years. Oh, I mean, to me, that is a big risk. Yeah. All right. So in a predictive project, business risks represent an opportunity for either gain or loss. Remember, we said that uh, a positive risk is an opportunity. Oh. Ah. So what you need to be doing is called project risk management. And naturally, since this is a predictive project, going to be putting together, and I'll spoil the PMI thunder, uh, put together a risk management plan up front, monitor it for the risks, adjust it as necessary, and then whenever any of the triggers occur, if they occur, we handle the risks based on the plan that we've put together. For an adaptive project or a hybrid, uh, we're going to be elaborating uh, the requirements at each of the iterations, each of the planning intervals, and each of the iterations. So that we're going to be using feedback to determine if we have risks and if any of the risks that we've defined, identified before, uh, have hit a trigger point. And so we've got a definition of business risks here. So we're going to be talking about predictive and adaptive and hybrid projects here. A couple of things that we look at is the organization's project risk appetite. And what we mean by that is how uh, how does the organization tend to handle risks? Are they uh, trying to be cutting edge and dealing with a lot of risk and understanding that uh, the projects need to be able to really be cutting edge with everything? Are they risk neutral? Is this something that uh, are the projects approximately the same all the time? Like a construction project uh, where you've done it many times before and all you're doing is repeating and repeating and repeating. Or are you risk adverse? Is the organization risk adverse? Where uh, the prime directive is do not have any risks. We want to handle those. We want to make sure that the project is unaffected by risks. Okay. Now, something that'll be established is a risk threshold. Okay. That's when um, you need to go outside of the project itself. So outside of the project manager in order to handle the risk. Okay. So you've got to be aware of the parameters for your risk threshold. So such questions as which risks are too high to accept? Right? What do you need to escalate there? Which ones are low enough to just be accepted? Okay. Or ones that you can small risks that you can handle. And you need to establish criterion or criteria that determine inclusion in the risk register that you're putting together uh, for the project. Now, you should have management guidelines for how to handle the risks, whether it's working with your uh, stakeholders on this risk or being able to identify uh, what other projects have done. Okay. Uh, one of there are two different types of ways to identify and quantify risks. One is qualitative, which kind of like t-shirt sizes uh, or just high, medium, or low, depending on what the organization usually does. Or quantitative, where you come up with a numerical rating for each of the risks. Okay? And one of the things is, as I mentioned before, set a maximum risk exposure level that can be managed without having to escalate. And you want to be able, as a project manager, to handle any of the small risks that come up and only escalate if something major comes up. For example, in our case study, if there would be a huge storm and most of the breakwater is washed away. Okay. that's something that would need an executive decision as to whether or not to continue with the project. Okay. So a couple of definitions. Okay. Again, we're talking about hybrid and predictive projects. Okay. So up front, while we're doing all of the project planning, we're going to set the initial risk strategy. Okay. And throughout the course of the project, we're going to be refining it as we learn more and more about what some of the risks may be, what some of the triggers may be, uh, the probability that a risk would affect the project, you know, things like that. So uh, there are a number of factors uh, in each project that you have to consider, like the size of the project, the complexity of the project, the importance of the project, and the development approach that you're using. So all of these can introduce risk. Um, all of these may contain opportunities to uh, bring the project in earlier, less, no, under cost, uh, things like that. Okay. So you create a risk management plan. Okay, and these are the components, minimum components that you need to consider for the risk management plan. The strategy, the methodology, uh, roles and responsibilities. You know, who do you have to escalate to? Funding that you have for the project, timing when the project needs to be delivered, the risk categories that you have, um, stakeholder risk appetite, and the rest of these. This is again, if you win the lottery and then the next day you get hit by a bus. Okay. Notice that the risk management plan is a component of the project program or portfolio management plan. Okay. So let's talk a little bit about adaptive projects. Okay. Um, with agile efforts, you want to identify what risks uh, can be expected for each of the user stories. There isn't uh, the extensive planning up front, although when you're starting an adaptive project, it does not hurt to actually I try to identify what risks can occur uh, in the project itself. There's a lot more discussion about risks um, at each uh, planning meeting. Okay, this uh, this is both the iteration planning meeting, the uh, interval planning meeting, and if risks may be something that may occur or need to be dealt with during a sprint, say, then you're going to be talking about them a lot more, either identifying them during the daily stand-up or the meet afters. Okay? And again, with the adaptive projects, you're going to be discussing these things a lot more. Okay? So uh, teams are going to use a risk register, which is just a listing of the risks and a few other parameters we'll cover in a little bit. Now, we'll make sure that everybody is aware of the risks by using our information radiators, whether that's a poster on the in the work area, whether it's electronic, at just some place where anyone who is affected by this project can go and uh, see what's going on. Remember, we had a very similar graph um, a lesson or two back about when you use predictive, when you use adaptive. Okay, so simple projects, predictive planning. You know what the requirements are. You know what uh, technology you're going to be using. It's somewhat consistent. It may be just another iteration of a previous effort. If it's a complicated effort where the requirements are a little bit mushy and technology is, you know, can be a, a little bit mushy too, then what you want to be doing is adaptive planning. That's also true for complex projects. Uh, if things get too far out of hand and you can't readily, I'm sorry, where the requirements, people are fighting over requirements, and say it's brand new technology that ends up in this area here, chaos, uh, you don't have a project yet. You've got people fighting, and you need to really establish a project by reining things in to at least the complex area, ideally complicated, okay, by refining the requirements, by understanding which technology needs to be employed. Okay, we let's address this first. Use of a prompt list to evaluate the external environment for risks. Uh, this is something that is, I'll put it this way, fairly gross, where you're not looking at specifics. You're looking at, put together a list of things like environmental factors, business factors. Uh, and we'll see this in another slide coming up here too. But it's really to stimulate discussion by the entire team. Uh, so for data gathering and analysis, you can use things like risk breakdown structure, and we'll cover this again, get another slide or two here. Brainstorming the techniques uh, that are brainstorming what risks could occur, what the magnitude of the risks could be, what the probability would be. Okay. Other things that you can use are SWOT analysis. Anybody know what an affinity diagram is? Oh, you knew I'd ask a question before 5:30. It's okay to just say no.
I don't know what it is.
Okay. An affinity diagram is when you have a whole bunch of points that you're dealing with. Well, and what you do is you uh, group them together, make subgroups of all the data, and take a look at where they have some similarities. Okay. All right, how about a Delphi technique? This
No.
goes
No.
this goes back to the Greek. Uh, Delphi was an oracle uh, who could see, was an expert at things. So the Delphi technique is getting multiple experts in and helping with the risk assessment. Now, Monte Carlo simulation is an algorithm for the risk assessment. It takes a while to set up, takes a while to run because you're doing multiple passes. That's why they mention here that it's for larger organizations. Oh, we got a whole lot here. Okay. So again, the prompt list is a series of broad risks. And we're going to see these in just a few minutes here. All right. Remember we mentioned risk breakdown structure? This is really a basic way of breaking things down. Your level one could be your prompts. Okay. What risks do you see under technical? Which management risks do you see? Commercial risks or external risks? And then responses would be in RBS level 2. Okay. So like technical risks, scope definition, management risks, operations management, commercial risk, uh, suppliers and vendors, and external risks being things like legislation, exchange rates, uh, things like that, environmental or weather. Okay. So these things fit hand in hand.
Now, what if you real quick now back to that list? What if you have to add to that? Can you add to that once you are? Well, I guess you will be adding to that, but since you already got the numbers there, do you just continue on in that? Like, say for instance, you have another technical risk, and you already got 1.6, so then you just add them for the 1.7.
Yep.
Is that you can? Okay, so you
Yep.
can do that. So
We're not. You're
okay.
not restricted to just this number of risks.
Okay.
Risk types to identify. This can go on ad infinitum. There may be other risk categories that you can think of for a particular project, add it in here. I have 5.1 through 5. Whatever. These are just
No,
models for you.
no, these typically like on an Excel sheet, or like how are these typically documented? Or they're like a
Okay.
program that has this?
Depends on your organization. This may be an Excel spreadsheet. It may be part of a tool. It depends on uh, how you set the project up, what tools you're using, and how you're coming up with these things. Okay. Any more questions? Okay. When you're assessing risks, remember we said there were two ways. One is qualitative, one is quantitative. Qualitative being things like small, medium, large, uh, or going through the full t-shirt size exercise. There are some tools that can be used. One is the probability impact matrix, which is uh, it's really straightforward. We're going to see that in the next couple of slides. Okay. Uh, Major risks that you identify may need a quantitative assessment to see exactly what type of impact they would have on the overall project. So we're clear on what we're talking about with the probability and impact matrix. Okay. It's mapping the probability of occurrence of each risk and the impact of the risk on the overall project. And the thing is that if you've got something that's like a very low probability of happening or having a very small impact, yeah, you may not have to go through the quantitative assessment. You can generally, if if you're doing t-shirt sizings, if it's an extra small, yeah, you know, if you have extra time, you might go through the quantitative. But what you want to concentrate on in uh, your actual assessments are the ones that would have above a medium impact. Okay, so uh, in this case, probability. If probabilities greater than 70%, and it's greater than 6-month hit to the project, uh, and greater than $5 million. Okay, that's a very high risk. All right. So these are the buckets you can throw them into. Okay, and these are good wet finger guesses that you're going to be doing, um, because unless there's a good history of the probability impact uh, definitions, this can be and this can be modified for each of the organizations. Okay, depending on uh, the risk appetite of the organization. Now, what you want to do is assess the impact and the probability. Okay. This is again a qualitative method of doing things. So across the top's impact severity. On the left side is the likelihood that something's going to occur. So just for example, a very low one would be low impacts impact to the project, and the probability of it occurring would be low. Okay. Come down here, the impact severity still low, but the likelihood uh, is there. Uh, it is very likely to occur. So for each of the risks, you'll evaluate them using a matrix like this. Uh, ones you really need to worry about are the ones in the dark red here, the 20s and the 25. 15, 16, 15, those are still high risks. And I would address the ones with the highest probability first. But all these need to be addressed. The medium and the low and the very low too. Now, you don't have to do a quantitative analysis on every one of these. If you've got something that um, is a low risk where the probability of it happening is pretty low, uh, you may not need to do a quantitative analysis on it. Okay, this is an example of a risk register. So in here, you'll have a description of the risk, the impact of what would happen if the risk is not mitigated or eliminated. They left this to the most casual observers. Impact level score on a 1 to 5 scale, probability on a 1 to 5 scale, and multiplying the two together, you get the impact times probability. And so what you want to do is concentrate on the highest risks first. Okay. So even though this impact is high, probability is low. So this is actually the last one that you would work on. Okay. Also list the trigger conditions. How does this happen? What do you see as leading indicators that this risk will occur? Okay. And then you should have an action plan for each one of these. And the action plan definitely does not have to fit within these squares. I mean, the action plans can be extremely, a lot more detailed to them. Come on. There we go.
So Harry, you got a question?
Yeah.
The risk score that's listed in this risk register, is it just an arbitrary score that's given, or is that like an industry calculated value? Is that something we're going to need to know for the test, do you think?
No. It's going to be your best wet-fingered guess.
Okay. All right.
Okay. You'll come up with probability, you'll come up with the impact level. What you need to know is how this is derived perhaps what the which one you should address first. Okay, so that you understand the concept of the impact probability matrix. And here's your formal risk register definition. All right,
Can you go back real quick?
go back. Yeah. Do you have a question or just need to get a screenshot?
Okay, just want to get a screenshot of that.
Okay,
Thank you.
sure. All right. Now, risk list. Okay, again, going through identifying the risks, probability, and impact on a 1 to 10 scale in this case. I would talk to the major stakeholders of the project, because this is, with the declining retail market, does the project have an opportunity to succeed? Okay, or are we going to be building buildings that are going to stay empty? Okay, and end up being an Amazon distribution warehouse. Okay. Now, you can add columns to the risk list. Okay. These are all good suggestions. Who owns the risk? What the status of the risk is? It's good to understand when the risk was identified and when it was resolved. Okay. Backlog. Okay. Well, it says backlog refinement process with risks added. The risks need to be addressed in the story. Yeah. If we've identified that a risk needs to be mitigated, whether it's or right up front or later in the efforts, it needs to go into the backlog and needs to be evaluated by the product owner. And when it is pulled into the sprint backlog, needs to be discussed by the entire team. Okay. Quantitative risk analysis methods. Now, these take a lot of time. Some of these take a lot of time and require tools to do it. Okay. The simulations, one of which is Monte Carlo simulations, requires some algorithms that you need some tools to be able to do that. Okay. You can go through and determine, do a sensitivity analysis, which where you identify which risks will have the most impact on the project itself. Usually, if it's a risk, it's not an opportunity. What we're looking at is could be one or the other or both of time delay or budget overrun. Okay. This
I
is
got a
called
question.
yeah.
Quick question. So it seems like a lot of this, and this is an observation. So when you're doing projects, it seems like there's a lot that goes into it. So is
Yeah.
there like a certain period of time that you are like I know every project is different, but is there like a certain percentage of time that should be dedicated to like the initiating and planning section of this, and then a certain portion to the executing? Also, like, are you like when you are a project manager, are you getting paid during that whole time period, or are you only getting paid when that project starts to like? Are you getting paid during the planning process and all the other stuff? Does that make sense when I'm asking? Like, do you have to
You
put that into the
darn well
budget? Like,
better be paid during the planning process.
well, I guess like if it hasn't started, like how does it?
It just
Does
depends
it
what
make
budget it's taken from. Okay,
okay?
uh, my experience with AT&T is there are some efforts that can be capitalized, some efforts that can't. The the planning is overhead, considered overhead. I've seen. Okay, so that would come out of a general budget. Once things get kicked off past your kickoff meeting, then uh, at least most of the rest of the work can be capitalized. That's where you need to work with your finance people and determine what which budgets the money's going to be coming out of. Okay.
So as a
So
project manager, you should account for your salary inside of that project, or are you saying that that's overhead like on the outside of the project,
um,
or does it matter on the project? Is every situation different?
it's how the organization handles things like capitalization, whether there is a single budget that is used for the entire project, or there are multiple types of different budgets that are used at different phases of the project. Okay. What somewhere you can capitalize the software development effort, somewhere you can't. And that's where you have to have the discussion with your financial team. They will tell you what uh, what can and can't be done. Okay.
Thank you, sir.
Sure. One thing you'll may need to know is expected monetary value. I think we get into decision tree analysis and influence diagrams in the next slide. But here are the sorry, definitions for this slide. Now, for both the Monte Carlo simulation and simulations in general, these are usually done by a team that is familiar with the tools and uh, you know, the situation. With these, you don't necessarily just walk up to them and be able to run them the first time. Okay. Okay. Decision tree analysis, influence diagrams, and expected monetary value. If you've got a fairly simple project, um, decision tree analysis is the way that you should go. You just put it together. It ends up looking like a tree. where each of the, an inverted tree. Or if you want to consider it a root diagram. The branches represent the decisions that need to be made, okay, or events that are going to trigger something. Identified with each with the associated costs and risks. Any of the endpoints of the branches represent the outcome. Okay. So if this starts to get too big, what you want to do is use influence diagrams as opposed to the decision tree analysis, because this can get way out of hand. You should have some documentation. What you need to do is investigate on your own what the influence diagrams look like, and you know, how to read them. Oh, sorry. Give me a second here. All right. So expected monetary value, you'll put together the decision tree. Okay. Understand what you're going to do is take your wet finger guess at the monetary value of a possible outcome and multiply it by the probability that's going to occur. You'll do this for each of the branches. And what you want to make your decisions based on is the highest expected monetary value. Okay. I'm not sure if the Mulcahy or the Crow or any of the books really go into decision tree analysis or influence diagrams too deeply. All right. Let's talk about time, cost, and life cycle of risks. Got a statement here. Predictive projects are most often affected by the impact of cost-related risks, whereas adaptive projects are affected by the impact of time-related risks. Do you agree, disagree, and why are you taking this stance?
I would agree.
Okay.
And adaptive along the way. You mentioned earlier things that can happen along the way that can either be positive or negative. That would, I would imagine, impact the risk along the way.
Okay. Anybody else?
I remember predictive being a little more structured around the costs.
Yeah.
And the adaptive, every time you do an iteration, the risk may change, right? And depending on what you want to address. So I guess that may, if it's impacting the iteration, then it's going to impact the time. So maybe that would affect adaptive projects.
Okay.
I'm not sure. I feel like I'm talking in a circle.
Well, yeah, because my humble opinion is that predictive projects can be impacted by cost-related risks and time-related risks. Right? Say you've got a construction project. Okay. You get a lot of weather delays on it. Those are time-related risks. Okay. So if you can't deliver on time, you may be at risk of having a viable project. Okay. I can see the same thing for adaptive, where the effort that's gone into it already to produce, say, a minimum viable product, plus a few iterations past it, um, you know, could be affected by both time and cost, depending on what the customer uh, needs at that point in time. So I think you can make a case for either one of these. Yeah. All right. Anybody ever have a date slip in a predictive project?
Yes.
Wow. I didn't know that they had those at AT&T. Just kidding. Um, what about in an adaptive project? Okay. They can occur in an adaptive project too, but I think they're more typical in the predictive projects. Here's a softball. Lack of clarity. Predictive or adaptive? Which one's most typical?
Adaptive.
Okay. Yeah, because you're starting out with fairly vague requirements. Now, even if you have a predictive project, you may not have identified all of the requirements up front. So there are occasions for each one. All right. So predictive projects. Risk responses need to be appropriate for the significance of the risk. Okay, if you've got a small risk, you don't want to be doing the same amount of planning as you would for handling a one with large impact. Okay.
You're not going out the window.
Say again? Okay. Projected solutions need to be cost effective. Okay, it doesn't do any good to propose something that's going to cost as much as the project itself. You've got to stay within certain guidelines. Okay. And if you identify the risk, it's a high probability of it occurring and it's a high impact, and the best you know about is going to have a significant cost, that's when you need to escalate. And along those lines, it's got to be realistic within the project context. Right? You don't want, you want it to keep the project on track, and you don't want to go outside of what the project is delivering in order to mitigate that risk. The risk responses, you need to run them by the relevant stakeholders and get their approval on it. And each risk needs to be owned by a responsible person, whether it's a project manager, a relevant stakeholder, a team member, determining who should be responsible for it. Okay. This is especially for predictive projects. When we set up our risk register, we also identified what trigger conditions, what forward-looking conditions would determine signals that a risk can develop. Not necessarily that it had, definitely not that it already has developed. But, trigger condition, risk, say for a hurricane. If the South Atlantic, the Atlantic and the Gulf of Mexico water temperatures are, just right, we can see that a hurricane can develop from that. Okay, no guarantee that it will, but it has a high probability. You want to work with the entire team to implement the risk response. There may be some people who are not on that risk response team, but it's more than one person who identifies it. Now, if you mitigate a risk, okay, what you can introduce is a secondary risk, meaning that your best efforts to mitigate that risk result in some other risk to the overall project. Call that a secondary risk. If you've resolved all the risks, okay, implemented all the risk responses, there can also be what's called a residual risk, meaning that you may not have gotten everything the first time. All right. So what you need to do is have a contingency plan set up in case the primary risk response fails. Okay, you want to have more than one way to address that risk. Yeah. So your contingency reserve, remember we talked about budgets last week. Okay. Remember, we had the cost baseline. We had a project contingency reserve. We also had a management reserve. The contingency reserve is the budget within the cost baseline that's allocated for identified risks and the response strategies. Okay. All right. Especially for predictive projects. What you want to be able to do is mitigate against threats and have a strategy to exploit any opportunities that come up. Okay. Right. So what we can do with a threat or an opportunity is accept it. Okay. Threats need to be mitigated, transferred to some other entity. This is where insurance companies come in. Okay. If you've got a risk of not being able to deliver a project, you generally your financial team will buy an insurance policy that you know, in case of like a natural disaster. You can also avoid the threat and figure out a way to get around it or escalate it if it's too high and you don't and you're not sure on how to deal with it. For opportunities, again, we can accept the risk. We can look at how we could enhance that particular opportunity, how we could expand it. We could possibly share an opportunity with another organization within the corporation. Have an idea of how we can exploit an opportunity. Okay, if say for example a customer gives us feedback on an adaptive project, and in giving the feedback identifies a potential extra market for the project or for a small modification to the project, figure out how to exploit that. And usually when there's an opportunity, you'll need to escalate it to the right stakeholders. And that's it. Any questions on risks? All right. We take about 5 minutes and give me a chance to reset here. And if you are able to get up, move around a little bit, at the very worst, move your arms or legs, get some blood flowing. Okay. Is everybody energized and ready to talk about quality? Oh, come on. I need to resound.
You sound a little far away.
That's better.
I
We can hear
was.
you now.
Okay. So is everybody re-energized and ready to talk about quality?
What, Harry?
Okay. Here's a definition that you do need to know, and I will read it. Quality is the degree to which a set of inherent characteristics fulfill requirements. These include stakeholder expectations and end user satisfaction. Okay. We want to make sure that the end users are satisfied. Definitely. Quality can mean compliance with standards and regulations. And if you have any continuous improvement goals for the project. I will get into each one of these in just a few minutes here. All right. Let's talk about the cost of quality. Right up front is the money that is spent during the project to avoid failure of the project itself. Okay. You can be proactive about it and have uh, what we call prevention costs. These can include training. It's needed for the project. I had one project at a place I worked at a number of years ago where the it's long before most of you have been around, but it was during the Reagan administration, and there was a language that was created called ADA, and we had a directive from a vice president to use ADA in this cellular simulator that we were building. In order to be able to do that, we had to go, each person had to go through about 2 to 3 weeks of training. Okay, so that, that was a cost of quality. And the thing is that the training paid off. We were able to deliver a very high quality product that was used for years. And avoided a lot of problems in the implementation. And we were able to swap out modules very easily. Okay. Having the right document processes and especially equipment up front to ensure success to the project and to deliver a high quality product. An investment of time to do things properly rather than just try and slam everything into the shortest scheduled time possible. If there are new ways that the project team is experimenting with or directed to use, then need the right amount of time. You also have to have, as I say here, the right resources, people, and equipment. And if there's something that needs to be done infrastructure-wise, you need to identify that and include that in the cost of quality. Another thing, especially if you're doing construction, is testing, where you need to verify that, say, the concrete that was poured is of a certain density, and by actually drilling cores in it, and also inspections, budgeting for that. Okay. The other alternative is we need to slap some Band-Aids on stuff we delivered that didn't quite work. Okay. If the customer comes back to us and says, it's not exactly what we wanted, or it doesn't work exactly like we figured, we have to go through a bunch of rework on the project, or you may end up with some or all of it being scrapped, right? Some of the other cost factors can be any of the warranty work that needs to be done, and any of the business that may be lost because of the delivery of poor quality. Predictive projects, remember? You'll create a quality management plan for the project. When you're going through all of the planning, when you're coming up with the requirements, is the time to do a quality management plan. Your overall organization should have a quality policy, either, number of defects, Sev 1 or Sev 2 defects that can be shipped with the product, or, something along those lines for construction. And one big thing, if your organization doesn't have a quality policy that applies to the project that you're working on, you need to create one. It's in your best interests. It's one of the requirements that you need to fulfill. So some of the parameters of a quality management plan, depending on your organization, the the management plan can be formal or informal, can be very detailed, or it can be somewhat broad, and that's going to be determined by your organization. Quality management plan needs to be reviewed throughout the project, making sure that quality parameters are still being met. And some of the benefits of a quality management plan being the sharper focus on the project's value proposition, anything available with cost reductions due to be able to ship higher quality, And if the plan is laid out and followed, can mitigate schedule overruns from rework. I've seen a lot of predictive projects go through a lot of rework. Okay. Excuse me. I apologize for coughing so much tonight. Get back there. So there are some things that you need to comply with. Both internal and external standards. Government regulations are a big thing. If you don't comply with all the government regulations, you may have completed the project, but it may not be shippable or usable. Okay. Any of your organization policies need to be complied with. Your product and project quality requirements and project risk requirements need to be complied with. Some of the actions that you need to take to make sure that you address the compliance of the project, classifying the compliance categories, determining potential threats to compliance, analyzing the consequences of non-compliance, being able to do a trade-off there, especially need to involve the key stakeholders on that. Determine the necessary approach and actions to address the compliance needs. Okay. In order to make sure you're delivering what will be saleable and what will be usable. All right. This matrix here that is differentiating between standards, regulations, de facto standards, and de jure standards. Standards, things like their example is the dictionary, language rules for regulations, de facto standards, that words that are used widely in groups like slang or jargon, which may or may not be incorporated into a dictionary. And the jury standards, regulations, words. Word enters a dictionary and becomes a defined word. Now, the other thing you can look at here is, okay, standards. If you have, well, let's go to regulations. National Electrical Code. If your organization has standards that exceed the regulations in the NEC, and these would be ones that are defined by your organization. You know, along the lines of the National Electrical Code, there can be conventions that use particular types of connectors or especially when something new comes out. There are certain regulations that you have to adhere to that are mandated by law, such as with grounding, and have to be basically approved by a body of experts. All right. You're probably not going to need to know for the test any of these organizations. The American Society for Quality is US based, Chartered Quality Institute, British based, and ASTM International would be worldwide. All right. All right. Time for you guys to talk. What standards and regulations are relevant in the area that you work in? Do you have any standards or regulations that you have to adhere to?
Installation standards, how we install equipment and maintain it, things like that.
Are those internal or external standards?
Well, we always develop our own stuff, right? But it uses the guidance of a lot of the manufacturers, so the externals as well.
Okay, great, thank you. Anybody else?
We have accessibility standards for the website for the
Okay.
visually impaired and all the necessary layouts and colors. So it used to be called Cato, now it's called accessibility. So we open a ticket to go through the assessment every time we start up a project. We also do security with CSO to assess privacy information if being used, and we have to
Okay.
answer a couple of questions to get past the audit.
Okay, great. Thank you both for those outstanding examples. Anybody else want to contribute? Football game hasn't started yet. All right. So let's hit quality metrics, checklists, and processes. What we want to be able to do is to keep track of key parameters that are going to allow us to assess the quality of the deliveries on a continuous basis. Okay. Now, the metrics may change from phase to phase or from iteration to iteration. The metrics can include checklists, templates, quality artifacts, and the quality that are listed in the quality management plan. Now, if you're talking about an adaptive project, the teams use retrospectives, and what they mean by small batch cycles is short the time frame for each iteration and gathering the feedback from the customer or from the product owner to make sure that the quality that's being delivered is what's expected or that we exceed it. All right. There are several different methods for continuous improvement. You may need to know the terms themselves, but you're not going to have to do anything with it. Six Sigma has been around for, gosh, 30 years, yeah, about 30 years or so, 35 years. And the framework that they use is called DMAIC, Define, Measure, Analyze, Improve, and Control. And the focus is on removing waste. Okay. Kaizen is change for better improvement. PDCA, see this, especially in adaptive efforts, plan, do, check, act, or plan, do, check, adjust. Okay. This is the concept Deming came up with. Agile methods, the methods themselves are not going to ensure quality. They're all tools that allow you to do things in a shorter period of time. Okay. So whether you're using Scrum, Kanban, and I've never known anybody to use crystal methods, but they're out there. They're different colored crystals for complexity of an effort. Okay. All of these will allow you to improve your quality. Scrum, especially the short feedback paths. Okay. Kanban, you can use Kanban methods for accounting for quality improvement. Okay, it's you need to be discussing it. You need to be planning for it. And crystal methods, your guess is as good as mine. And that's it on quality. Do you guys want another 5 minutes, or do you want to just rumble through the final one?
Good if you are.
Okay, let's go through it.
Yeah, let's keep going.
All right. Hmm. Okay, last topic for tonight is integrating plans together. Now, I'll warn you, this is a long section. For predictive projects, it's important to take all of the plans that you've produced, the scope, schedule, budget, resources, and all that, and integrate them into a single plan. Okay, single view. Give you a better opportunity to identify and correct gaps or discrepancies. Can use them to align how your team's working with each other and improve the way that the team works together. It would also help assess and coordinate the project during its life cycle. So the result of this step is our wonderful integrated project management plan. Okay, for predictive efforts, we're going to have a large planning phase up front where we're going to produce all of the plans for the project. Okay. At the end of the planning stage, you want to put everything together. That is really, when you get everything together, is when the planning stage completes. And again, it's project manager's role and responsibility to produce this integrated plan. With hybrid projects, we're going to be doing is less of the gross planning up front, okay, so that while we're working, we're going to be putting things together, right? Identifying where we need additional planning that needs to be done, and doing that as the project progresses. So for adaptive efforts, you're not going to have you'll have a framework for what you want to accomplish. You're going to have changes to that based on customer feedback, and you're going to adapt your plans based on the best knowledge that you have at any time that you're looking at it. Okay. All right, predictive projects. The most fun thing about predictive projects is change control. So you're going to produce a change management plan, and that's going to tell everyone, let everyone know what the process is for proposing a change, delivering a change, and who needs to be involved with assessing the changes. So some questions here. Who can propose a change? Is it just a stakeholder? Is it just a project manager? Is it also include development team? Okay. And what exactly constitutes a change? Now, remember we were talking about thresholds a week or so ago, where we determine, what is a change that can be absorbed within the project and what changes need to be approved and taken to stakeholders. Okay. The other things we talk about are what the impact is on the project objectives. Okay, are we still in line with what we signed up for? Why is this change necessary? Also, who and what is involved in evaluating a change request? Okay, you have to have the right people reviewing each change request. I remember when I was working on UVerse, we had sometimes 20, 30 teams that had to sign off on change requests because everything affected everybody else. Again, the approval levels. Okay. You generally have a change control board that has some power to accept changes, uh, reject changes, and there may be things that are totally out of the scope of the change control board. So that's when things get escalated. Your change log should be used to record information about the change. You know, what prompted the change, who asked for it, whether it was approved or disapproved, and what the actions are going forward. And then monitoring the actions to confirm compliance and quality. You've got quality metrics that you've established for the overall project. We talked about the RACI charts before, so that there may be some people who need to approve the changes. And then it's also mentioned is the information radiators to make sure that everyone knows about the changes. And we got a change management plan and a change request. Okay. So we're going to be talking about both predictive and hybrid on this slide. One second here. All right. With systems-based changes, what you want to be able to do is decouple the parts of the system, and if there's a change that's necessary, reduce the number of variables that are impacted by it. That ADA effort that I was talking about a little bit ago, we had about 350,000 lines of code in it. And part of the, one of the big features of ADA was complete decoupling. The only way that any routines could talk to each other was through a compiled interface where it was range checked and type checked by the compiler itself. Okay. So that we were literally able to take out modules and plug other ones in. and we used a lot of commercial off-the-shelf software, and sometimes replaced that when that wasn't sufficient. uh, so planning for your complexity in systems-based situations is you may be able to do some analogous, find some analogous systems and figure out from that, what the impacts would be. Another thing that you can do is reframe the problem. Get a number of people to take a look at it from different perspectives. And if it's system-based, you're going to have people working on various aspects of the system. Employ them to, excuse me, look at the problem from some different perspectives. Okay. Especially for hybrid, you're going to be planning iteratively and addressing, say, one feature at a time. Okay, rather than trying to shove everything into an entire system at one time. Okay. Make sure that you're working with the stakeholders, with your product owner especially, to make sure that you're producing something that the customer is going to want. And then, most of all, plan for things not going right, especially the first time. Always have at least one alternative way of addressing an issue. When we're talking about hybrid efforts, you'll do some general planning up front. Nothing as rigorous as with a predictive project. As you move forward in the project, you're going to tailor processes, tailor your plans, determine what's, make sure that things are adaptable when they're created, and they, sorry, they're resilient enough to handle the changes. Okay. And one good piece of advice here is what you want to be able to do is adopt mindsets and frameworks that prioritize collaboration over instruction or direction and control. And that was the monster section here. Any questions? All right. Well, I'd like to thank you for attending tonight, and I'll be back with you next Monday. And you will have someone else will be leading the workshop on Wednesday. Okay.
Yep. Thank you. Thank you so much.
Thank you.
Have a good
Thank
night.
you.
Oh, and
Thank
one
you.
thing, one important thing before you go. If you haven't voted, please vote.
You got it.
You can count on it.
All
Have a
right.
great night, Harry.
Have a good night.
Already did early voting.
Good night, Harry.
Sounds good. Bye.
Night.